Dad, Harry is suffering at the Dursleys. He's locked up in his room and unable to receive any communication from us.
Listen, son, there might be a way to get Harry out.
Dad, you better not be thinking of doing you know what.
Fascinating, ingenious really, how Muggles have found ways of getting along without magic.
That's against the law, Dad. You're the head of the Misuse of Muggle Artifacts Office at the Ministry of Magic. You will get into trouble with the law. Not to mention, Mum will be furious.
Well, there's a loophole. I wrote the law, so I should know.
The Misuse of Muggle Artifacts Office is the most boring department. It has everything to do with bewitching things that are Muggle-made.
You should take more interest in Muggle studies, son. The law says, as long as I'm not the one intending to use the magical alteration.
What are you planning on doing, Dad? What Muggle device are we going to use to get to Harry?
Why, a car of course. I'm going to bewitch it to fly.
That's a bad idea, Dad. Remember the story about some old witch and her tea set? She bewitched the tea set, and after she died, it was sold to an antique shop. A Muggle woman bought it, took it home, and tried to serve her friends tea in it. It was a nightmare. The teapot went berserk and sprayed boiling tea all over. One of her friends ended up in the hospital. You had to do memory charms and all sorts to cover it up, remember?
It won't be like that, Ron. I'm not some old witch. Trust me, child. I know my way around a car. I've been collecting batteries and plugs since before you even existed, child.
Whatever you do, we need to keep this a secret from Mum. You know how she is.
We can consult your friend, Ron. What's her name? The Muggle-born.
Hermione?
Yes, Hermione. Her parents are Muggles, aren't they? They must know a lot about cars.
Hello, Mr. Weasley. Hey, Ron. Did I hear someone mentioning a car?
Perfect timing, Hermione. We are planning to bewitch a car to fly to rescue your friend Harry from the Dursleys.
Mr. Weasley, a car is a complex machine. My dad said it is best to leave it to the experts whenever there's a problem with our car. We always go to an authorized dealer.
Don't worry, Hermione. I'm just going to give it a slight boost. Nothing too extreme, I promise.
Hermione, maybe we can help Dad out. Can we use data science to figure out which Muggle car to get?
That is a fantastic idea, son. Hermione, if you could analyze a bunch of cars for me...
I guess we could attempt to group cars with similar traits and features together. That's it, Hermione. It's like a classification problem, isn't it? To classify cars into different clusters based on their features.
Then I can simply choose any car within a particular cluster, as cars within each cluster have similar features, right?
That's right, Mr. Weasley. Leave it to me and Ron.
Alright then, very good. Here, you find this useful. It contains my notes on 50 car brands that I've collected over the years.
Thanks, Dad. Hermione, look. Dad collected data on 4 features: horsepower, engine strength, airbag efficiency, and turning radius. Having a good airbag is important, especially if your dad is planning on bewitching the car to fly. Let's start by scaling or standardizing the data. Why do we need to standardize the data, Hermione? Can't we just use the raw values? We could, but it wouldn't be good as the variables have very different ranges. To solve this problem, we can simply use the scale function to transform the data to have a mean of 0 and a standard deviation of 1. Cool! That looks great! The classification of cars into groups requires us to compute the dissimilarities between each pair of cars. Yes, the result of this is known as a dissimilarity or distance matrix. There are many types of distance measures, but let's use the Euclidean distance, which is the shortest distance between 2 points. We can use the FactoExtra package for this. It has useful functions such as getDist for computing a distance matrix between the rows of the dataset, and default distance is Euclidean. Perfect! We can also use the fvisdist function to visualize the distance matrix in a heat map. Whoa! So red represents pairs that have large dissimilarities, and turquoise represents those that appear to be rather similar. Yup, now that we've visualized the distance matrix, we can perform k-means clustering, which is a type of unsupervised machine learning to partition the dataset into a set of k clusters. we can start with 2 clusters by specifying centers equals 2. nStart equals 25 means that the algorithm will generate 25 initial configurations.
Looking good, Ron. According to the results, the sizes of the 2 clusters are 30 and 20 cars respectively.
The fvis cluster function allows us to visualize the 2 clusters. Take a look, Hermione.
Not bad. The separation between both clusters looks reasonable. Let's try different Ks and examine the results.
Okay, we can try 3, 4, and 5 clusters and plot all of them to compare the results.
We can also use the grid arrange function to get all 4 plots at once.
That is amazing, Hermione. Based on the graphs, we can see whether the clusters are well separated or not. However, the graphs do not tell us what the optimal number of clusters is.
You are right. There are a few methods to determine the optimal number of clusters. Let's explore 2 methods today. The first is the elbow method.
Elbow? As in elbow?
Yes, elbow, as in that area of your arm. Basically, the main idea of clustering is that we want to minimize within cluster variation. Therefore, for each k, we can calculate the total within cluster sum of square using the fvis mbclust function by specifying the method as WSS for within cluster sum of square, and then plot the values according to the number of clusters. Take a look, Ron.
Whoa! I see what you mean by elbow. The region where the line starts to bend, like an elbow. The elbow occurs at k equals 4, which suggests that the optimal number of clusters is 4.
That's right. We can also use another method for determining the optimal number of clusters called the average silhouette. This method measures the quality of clustering by determining how well each object lies within a cluster. Take a look.
Ooh! I guess the higher the average silhouette value, the better the clustering?
Indeed, the graph shows that the maximum average silhouette is reached with 2 clusters.
Interesting. So the elbow method indicates that 4 clusters are ideal, but the average silhouette method says 2 clusters.
Let's go with the average of 3 clusters then, for simplicity.
Okay, let's generate k-means clustering with k equals 3 and visualize the clusters using the fvis cluster function.
Amazing! So it looks like the cars are nicely separated into 3 clusters. Interestingly, Ford is clustered with brands like Suzuki, Volvo, Land Rover, and even Ferrari.
Those are great brands. I know Dad likes Ford. Let's show him the graph.
Hurry up, Ron! Harry's waiting for us!